All right, guys, this is our AP lecture for the week. This is what we went over in 0 hour. Sorry about for putting it up so late. Things got busy this week. But anyhow, we're going to be spending a few weeks on vector math because as we get into forces in particular, we're going to have to learn how to add and subtract vectors if you are an AP student. You will see a lot of vector problems if you actually take the exam, and you'll also see some vector problems in our studies. So first of all, remember, let's refresh what a vector is. A vector has both a magnitude, right? That's just a number. And it has a direction. Now we can represent a vector with an arrow. The length of that arrow represents the magnitude, and the magnitude of a vector is designated by this. I'm just going to call this vector V. We put this, those double bars on both sides would represent the magnitude of the vector. And when you put the magnitude on, the magnitude of the vector is actually a scalar, okay? And so this length here represents the magnitude of the vector. When we talk about the vector along with its direction, that's when we use the vector sign. So the magnitude of the vector doesn't need the arrow, the vector does. And this would be the direction. Okay, so when we talk about direction in physics, we are literally talking about the same way that direction is handled in math class. Okay, it's from the x-axis and it goes counterclockwise. That would be the angle theta. So if the magnitude of this vector happened to be, I don't know, let's just say 10 meters per second, 10 newtons of force, whatever, and this angle happened to be 30 degrees, then this vector would be specified by 10 meters, 30 degrees, and it's implied that this vector is starting 30 degrees going in the counterclockwise from the x direction. When we deal with navigation problems later on, you're going to get terms. In fact, if you're in pre-calculus, you'll get that later in the semester, second semester, the terms of bearing and heading. And those are used by the marine industry, the airplane industry, when they talk about directions that boats and airplanes are heading. And that's something different. And that always starts from due north and it goes clockwise. But for right now, we're going to use the term direction, and direction is exactly the same as in math class. Here's two vectors. Okay, and I'm going to call this vector 1, and I'll call this vector 2. And one is at an angle of theta, and the other one is at an angle of alpha. Now, vectors can be added, vectors can be subtracted, vectors can be, you're going to be learned that vectors can be multiplied, but for the most part we add and subtract vectors in physics class. That's what we almost always do. If I know these coordinates here, and I know these coordinates, adding and subtracting vectors is really nothing that you haven't done in math class before. But let's just take a simple case of vector addition, all right? Let's just say I have a vector this way, and I'm going to call this, 1, 2, 3, 8. 8, and what's its direction? It's 0 degrees. And I'm going to take another vector over here, and we're going to call this a vector of 4 at 0 degrees. How would I add those two vectors? Well, when vectors are in the same line, whoops, I didn't see that, got off the map here. get off my viewing thing here. Okay, so again, a vector of 8 with a direction of 0 and a vector of 4 with a direction of 0. So when vectors are in the same direction, we can just add them up just like you would think. And so this method of vector addition is called head to tail addition or subtraction. Okay, so I'm going to take or sometimes really the tail to the head. I'm going to take the tail of this vector. This is the tail, this is the head. And I can take and move any vector as long as I don't do two things: change its length and change its direction. I can take this vector and move it up here. And now I would have the effects of adding these two vectors. And my resultant vector, that's the term that we use. We use the term resultant vector. I'm going to specify that by r, would then be equal to 12 heading in the 0 direction. So adding and subtracting vectors when they're in the same direction is just intuitive the way you would think. What if I wanted to subtract those two vectors? Okay, let's subtract those two vectors. Again, here's my one vector, and we're going to 8 in the 0 direction. And we have 4 in the 0 degrees thing. Where are we going to be doing this? It really becomes obvious when we start talking about forces. In this case, maybe one person is pulling on with 8 pounds of force, and this person is pulling on with 4 pounds of force, and the resultant is we'd be pulling in this direction with 12. But what if someone is opposing? What if someone is pulling in this direction with 8 and someone is pulling in that direction with 4? We do exactly the same thing. We would take the tail of this one, add it to the head, and go in that direction, and then this here would be my resultant vector, and of course that would be 4 also heading in 0 degrees. If we did that in the opposite way, if we took a vector of 8, I'll use the term 8 meters at 0 degrees, and I took a vector of 12 meters at 0 degrees. We always got to have units. I should have been using units. And I want to subtract vector 1 from vector 2. How would that work? Well, it works pretty much the same way we've been doing things here. There is vector 2, and that's 8 meters in 0. Now, what if I want to subtract this one? Well, I got to take the tail of this, add it to the head of this, and I'd come all the way over here. Okay, and my resultant vector then would just be this, and that would be 4 meters. But what would now be my direction? Well, I start here and go all the way around, and that would be 180 degrees. All right, so I'm going to make a couple. I got to make sure all these things stay on track here. So again, this is where I take vector 8 in this direction, and I want to take this vector and add it in the negative direction, and I come up with, I just go take the tail of this, add it to the head of that, go in the negative direction. That's subtracting. Okay, subtracting vectors is nothing more than adding one vector and the negative of the other vector. And now I would be in the 180 degrees. Okay, this is a simple one on adding vectors in the same direction. I'm going to actually put up a little, it's called an interactive on adding and subtracting vectors. So I'll have you watch, but I'm going to do one more short video when they're not in the same direction, and I'll make that here in a minute, okay?